Hello, I am Axmedova Aziza, an English teacher of Bukhara State Pedagogical Institute. And today our theme is about Introduction to Geography. We talk about weather and climate and Introduction to Geography, people, places and environment. So you can see in this picture, weather and climate affect us in many ways. How climate affect us, housing, dress, vegetation, sports, and then major factor in habitability of areas, affects human comfort levels, affects the costs of living and working in an area, extremely high cost of mineral extraction in mineral-rich Siberia, affects the agricultural products that can be produced. Weather and climate. Weather, day-to-day variation in temperature and precipitation. And about climate. Statistical summary of weather conditions through time. Definition: the average yearly pattern of precipitation and temperature. Weather and conditions. Example: storms, temperature, movement of energy, fundamental features of Earth's surface, regulate natural systems, limit human use of environment. About weather and climate. Whereas climate is the average annual pattern of precipitation and temperatures for an area, weather is the momentary and very temporary condition of the atmosphere. Weather is experienced moment by moment. To experience the climate of an area, one must live there for many years. To truly experience climate, one must experience the extremes as well as the averages. And about solar energy. Radiant energy from sun powers circulation of atmosphere and oceans and supports life on Earth. Varies across Earth's surface. Insolation, amount of energy intercepted by Earth. And two factors: intensity of solar radiation, duration of sunlight. Intensity of solar radiation. What does it mean? Angle of incidence varies daily and seasonally. Lower angle, larger area, lesser intensity. Higher angle, smaller area, greater intensity. So, Earth-Sun relationships. Even in ancient times, humans were able to observe that the relationship differed from day to day in a cycle. About air temperature. Earth's inclination 23.5 tilt of the axis is responsible for the seasons and redistributing the heat energy received. Reflection and re-radiation. Human actions can affect this. The lapse rate 3.5 per 1,000 feet. Decrease with ascent, increase with descent. So latitude. Sun is directly overhead at the equator. March equinox, March 20 or 21. September equinox, September 20 or 21. June solstice, June 20 or 21st. Tropic or Cancer, December solstice, Tropic of Capricorn. Hemispherically correct terminology used above. Length of day. Total heat received by a place is dependent upon the number of hours of sunlight and its intensity. Equator, higher latitudes. Seasonal change in insolation in the middle latitudes. The angle at which the sun's rays strike the earth change from day to day as a result of the tilt of the earth's axis, not because the sun moves. And you can see the photo about what if the axis were perpendicular, with the axis perpendicular to the orbital plane. For example, very much colder, much hotter, possible uninhabitable, and the direct rays of the sun would strike at the equator 365 days a year and very much colder. Seasonal variation in radiation varies because of angle of incidence, day length, distance from sun, equator, high latitudes, and temperature. Tilt of the earth axis, responsible for changing lengths of days throughout the year, responsible for seasons, responsible for variability of insolation. Energy balance. You can see in this photo about Earth's energy budget. Solar heat storage. Heat is absorbed by and released from objects. Water absorbs and releases more heat than land. Land heats and cools more quickly and to a greater extent than water. Water is a moderating influence on temperatures. And you can see in this photo differential heating of land and water. Adiabatic process. Water vapor in the atmosphere affects the heating, cooling rate of air. Latent heat stored in water vapor affects temperatures, and latent heat exchange, transfer of heat from lower altitudes to higher ones, is very important in causing precipitation. And now also the picture about the three states of water. Heat transfer, responsible for movement of energy from place to place on Earth, radiation, electromagnetic waves, heat. Greenhouse effect, short, long waves, greenhouse gases, critical to heat exchange, water vapor, carbon dioxide, ozone, methane. Increased greenhouse gases, increased global warming. Latent heat exchange, transfer energy from low to high latitudes, causes precipitation. Two types, sensible, detectable by touch, and latent, in storage in water and water vapor. Latent heat exchange, adiabatic process. Heat exchange and atmospheric circulation. Convection, upward movement of fluids caused by heating. Boiling water, atmosphere. Advection, horizontal movement of air, and monsoons. Wind definition. Wind is a horizontal movement of air from a high pressure area to a low pressure air. Sea breeze. So you can see in this photo about sea breeze circulation. The first one, warm air over land rises. The second one, sea breeze moves inland. Third, cumuli develop aloft and move seaward. Fourth, upper level return land breeze. Fifth, cool air aloft sinks over water. And the last one, sea breeze. Also you can see land breeze circulation. And about radiation, heat and migrating tropical low. The tropical low, driving engine of the wind system. There is a seasonal lag in the shifting of the wind belts. Hydrologic cycle, temperature precipitation relationship. Water vapor is continually changing from a gas to a liquid and from a liquid to a gas. Precipitation, normal precipitation, condensation, conversion of water from vapor to liquid state. All air holds water, depending on temperature. Saturation vapor pressure, maximum water vapor air can hold at a particular temperature. So relative humidity, water content of air, percent of water air could hold at a given temperature, fluctuates wholly as temperature changes. Precipitation, and there are three types of precipitation: convectional precipitation, warm humid rises, expanding and cooling. Saturation point is reached, clouds form, adiabatic cooling. Decrease in temperature that results from expansion of rising air. And convectional storms. Orographic precipitation. Wind forces air up and over mountains. Rain on windward side. Desert on leeward side, rain shadow. For examples, Cascades and Sierras, Rockies, exception, Appalachians. Frontal precipitation, air forced up a boundary between cold and warm air masses. Air mass, region of air with similar characteristics. Cold front, cold air mass moves towards warm air mass, typical weather. And you can see in this photo warm air front, cool air. Frontal precipitation, curving and rotation come from this effect. Frontal precipitation, normally a mass of a warm air rises above a mass of cooler air. When the two masses meet, as the warmer mass cools, there is condensation and possible precipitation. Circulation patterns, air mass, atmospheric pressure, various and altitude, higher altitude. Barometer maps use isobars. And about jet streams. Fluctuations in the jet streams affect the behavior of various air masses. Their immediate effect is on weather. Pressure and winds. Air density, warm air, pressure gradient, difference in pressure between two places, Coriolis effect, indirect curving path of winds caused by rotation of the Earth. Global circulation, 4 zones, intertropical convergence zone, convectional precipitation, trade winds, subtropical high pressure zones, areas of dry, bright sunshine, little precipitation, mid-latitude low pressure zones, polar front, polar high pressure zones, and seasonal variations. And you can see in this photo wind belts. About monsoon, A seasonal shifting of wind direction. Our water world. Surface 70% water. Water moves horizontally, vertically, and obliquely. Some movement results in heat transfer, some movement doesn't transfer heat. Ocean circulation patterns. Wind creates waves and currents. Characteristics of ocean currents in the three-dimensional oceans. Cold, warm, high salinity, weakly saline, occurring at great depths, occurring at intermediate depths, occurring at the surface. So you can see here prevailing winds influence ocean currents. The ocean roles in the ecosystems. About storms, cyclones, hurricanes and typhoons. Climate summary of weather conditions over several decades or more. Influences change over time, humans and climate. Two primary measures, temperature and precipitation. About air temperature, precipitation, variable between places and through time, worldwide variation, global circulation patterns, amount of precipitation, reliability, regularity, and others. Classifying climate allows analysis and planning. Köppen system. So you can see climate regions, climate variables, latitude, attitude, maritime influence, pressure systems, prevailing winds, ocean currents, storms, and topography. Climate change is very complex. More about climate cycles, solar powered world. So more solar powered world. And others. So that's all for now. Thank you for your attention. Goodbye.